Hey, I'm Anfa. I'm the lead developer on Liblast, which is a free and open source multiplayer shooter, first-person shooter developed with Godot 4 and a fully open source toolchain. Am I streaming? Yep, looks like I'm streaming. In this video, I want to show you around and break down how I made a dynamic display on the weapon that you might have seen in a video that I published recently. So first, let me show you what that is, if you didn't see it. So you can see on the top, on the bottom right, in the bottom right, we have a gun model with 3 glowing bars. And if I shoot, you can see that things happen. For example, the blue bar gets smaller. Now it's orange. Now it's blinking yellow to orange. Now I reload, and it's blue again. And also, we have 2 other bars. One is greenish, and the other is purplish. If I shoot a secondary mode, oh, I see one shader isn't working. Yep. But you can see that the purple one, misclick, is also changing, animating. I don't know why that shader doesn't work. I've been fixing some shaders that were broke in a recent Godot 4 beta 14 update. All right, so I'm going to show you how I made these animated displays and some ideas that I have to make that kind of flexible. Keep in mind that this is quite early and this is very, loose and kind of improvised stuff, so don't expect it to be rock solid or super well architectured and stuff. Okay, so what we have here is the weapon scene. This one is called projectile shooting weapon. That's because it's basically a test for a projectile. Derpy Ninja Frog says hello. Hi, Derpy Ninja Frog. Welcome to the stream. Right, so here we have the weapon model. This is the weapon scene. And how this looks is model is the parent for all the imported visual things. So plasma gun is basically the GLTF scene I exported from Blender. As you can see, scene plasma gun.gltf. So it's this model basically raw with just all the meshes separated. And here I added a few elements. So first I made this ammo display. And the idea here was that this little model here, this little canister is, say, a battery or something. Actually has metal contacts here. And that, it stores some energy that this weapon consumes and turns it into projectiles. So first I made this, which was just a decorative element. Actually, there is no geometry here. This is, just a texture, as you can see. But then I thought, I can turn this into something useful. So I've added this plane, this mesh, and what I did is just, created a mesh instance node, mesh instance 3D, then created a quad mesh, scaled it, dialed in some dimensions that fit right in. I moved it into position, and then the interesting part is the shader and code that runs it. But first the shader. So there's a shader I've made called weapon display. Let's open it. This is a visual shader. Pretty much all the shaders I do for Liblast are visual shaders. I find making shaders, unless they're very simple, I guess that like working with visual shaders for me is a very nice thing. I don't want to code if I really don't have to. Maybe I'm gonna undo the, yeah, moving this around. Don't want to break something. Right, so we have this shader, display ammo. And this shader exposes a few instance parameters. So let's take a look. Like there's a couple of things that are here, like albedo and metallic is set to 0, just, you know, hard value. If I set it to 1, this becomes kind of grayish, as I want a black background. Roughness 0.5, this is, you know, it could be small roughness, so the displays would be more glossy, but I didn't want to have like, you know, harsh highlights on these. Kind of like a matte finish display on, you know, on a computer screen. And now the actual interesting part happens in the emission channel. Maybe I can move this up actually. And emission. Let me go to the very beginning. So first we have UV. I'm going to do this. If you take the UV coordinates of this quad mesh, what we have is basically two gradients. One goes from left to right, the other goes from bottom to top, or top to bottom. So these are two coordinates of the texture space, U and V. So here what I do is I split these coordinates and just take the horizontal one. If I route this into output, you can see that we have a gradient that goes from left to right across the whole quad. And this is the basis for all the animation of a progress bar kind. So what I do is then I do a comparison to determine which pixels on the screen have this value, this coordinate value larger or rather smaller than a certain threshold. So after thresholding, we get this. So we are cutting off at right now exactly 0.5, so right in the middle. You can see that half of this bar is black, half of this bar is white. That is exactly what we want. Actually, I could maybe play a little animation. Oh. Yeah, just to see the entire thing. Right, so here we have a fellow parameter value. What you do is to create something like that is just type in parameter. And you can then create a float parameter, for example. Now this one is per instance. So if I call this something and just have it like that, it needs to be actually used somewhere to be even compiled into the shader, because the optimization is just going to discard this thing. But if we connect it somewhere, then in the shader settings, it should appear. However, sometimes I've seen that you need to switch away and switch back to it. Qualifier none. Okay, I don't see the. And there's instance shader parameters, but there is no basic shader parameters. Yeah, I don't see them. Okay, never mind. If we set it to instance, what we're doing now is having this value be changeable for every object in our game, pretty much. So we can use the same exact shader, but give it different values and different objects or different mesh instances, and it's going to give us different results, which is fantastic. Now, there is a instant shader parameters category in the geometry instance 3D node, and I need to switch away and back. Maybe it's like discarding this as not useful. I'm going to switch it to something else. Okay, now we have something. Yeah, so I guess the shader compilation determined it's not actually doing anything. Yep, so we have our something here of value 0, and this is per instance, so I can duplicate this display a few times like I did here, and you can see that this display can have a different value, and this display can also have a different value. Let's go 0.2. So these are free objects that are using free meshes that are using the same shader, and thanks to the instance shader parameters, they can have a unique look, which is great because in Godot 3 you pretty much just have to duplicate your shader in code, and that's very unoptimal and cumbersome. So yeah. Also, if you're coming from, you know, shader programming, parameters are just uniforms. They were called uniforms before, but it's confusing to artists, so they were renamed to parameters just to make things easier for people who aren't used to writing shader code, which I think is fair, because I think most game programmers won't have experience writing shaders, so honestly, I don't know why these things are called uniforms in shaders. Why not variables or something else? Yeah. Okay, so we have our threshold, our float comparison node. So we're checking wherever the value of the v coordinate is larger or smaller than our value here. We can provide the default one, and it has to be an instance thing. Then what I'm doing is I'm applying a color. I think, no, what I'm doing is something else. So here, let's take a sneak peek at another part of this shader output. So here is something interesting. I take the UV shader again, and I compute a remainder of it. And what this is pretty much, it's the modulo operation, or modulus, which creates a repeated gradient with interval of this length. So if I change this to say 0.1, I'm going to have 10 iterations here. 1, 2, 3, 4, 5, 6. And I've just realized this isn't doing what I thought it's going to be doing because... Or is it? Yeah, honestly, I don't know. Because I thought it's going to be horizontal. But of course it's not, because it's going to be taking the first component. Decompose, vector2 decompose. Let's reroute this here. Oh, we can't. Can we? Can't we? Oh yeah, we can. Okay, I just did it. And let's use this one. Right, so now we have a horizontal thing with, we can treat this like, you know, we have a grid. Now, having this comparison, I'm not sure. I think I'm just cutting out part of this. Oh no, it's never gonna work because, yeah, I think I'm doing nothing pretty much. I think I was trying to make a grid pattern. We can actually do it, but yeah, it needs to be a little bit different than what it is. So we can have like a little, you know, ruler. We just need to take the horizontal component. Yeah, so now if I also threshold this, we can a little bit of a grid pattern like that. Now, if I multiply my previous thing by this, we basically get our bar with a little bit of gridding. The problem with this is, however, is that these grid units aren't going to be, you know, we're not snapping to our grid. But this is something I didn't really do. So maybe we could do it. Let's leave it as it is now. I'm going to explain everything in depth, and then we can come back and extend this to actually snap the value to grid to make this work like, you know, like bars, parts of the progress bar or something. We could have another uniform parameter expose that would say how many divisions of the grid we want. And then it would always snap the values to that, to like, you know, we could then have one bar, meaning one shot, for example, depending on how much ammo your gun holds and consumes, etc. Okay. Maybe, yeah, let's keep it at that. Okay, now what we're doing here, we're multiplying by something. What we're multiplying by is a color. And this color is determined here. There's a switch. And that switch is driven by comparison. We have a warning threshold. The warning threshold is also defined per instance. I don't know why it's not here. Probably because we changed the routing. Yeah, now it's here. So warning threshold. I don't know why it's like, it's not properly showing in. Yeah, it's not properly showing here. It should be 0.15. So what this should do is let us just set the color to a different one in case the value is smaller than X. So by default, we have this color. And because we changed things around, this changed to, you know, a different value, but it was, you know, something like that. And then our warning threshold, oh, now it works. Okay, if I go to 0.2, we're here. If I go to 0.1, ta-da, we have our warning color. So basically the value that we're feeding is now smaller or equal than this threshold, which drives the switch, which feeds this color instead of that color. And this is multiplied by our bar shape, which gives us the shape that we have. Now there's another switch here. Let's see what it'll do. Recompiling shaders. So actually we can delete this something because it is not needed and it actually doesn't do anything. What is here is if we set the value to 0, we get this special case where the entire thing that we had before is overridden with this switch, and instead we're fed this. So here is compare. First, we're checking if our value, because this takes the value, is equal to 0 with a small tolerance, because floating point numbers can be weird like that. Daniel Sokil asks, this will display ammo count. In the future, I'm thinking about extending it to, like, you know, display a text. So it might be easier to display text using a label 3D node instead of in the shader. So doing it in the shader gives them more options to, you know, integrate it into this display. So I'm not sure. Maybe both, maybe different things. I don't know. I was initially thinking about displaying numbers, but this was the first move to just make animated bars. And for now, I think it's pretty okay. It does its job. Right, so this is a empty state. When this value is 0, that means the magazine is empty. And then we're displaying an animation. Oh, middle clicked. What I'm doing is taking time input, which, just goes from 0 to plus, and I'm calculating a remainder with 0.75, which means I just have a cycle of 0.75 seconds, because this is a float and counts up in seconds. So now I have a pulsating pattern. Okay, what can we do? We can convert that into a texture coordinate. So we use the time input as a horizontal coordinate, and we just set the vertical coordinate to 0.5, which doesn't really matter that much because this texture is uniform vertically. And then I create a texture 2D, which is a gradient. I'll just define a gradient that has, some black, then yellow, then goes to red and black again. And sampling this texture using that vector here gives me this animation, which is just, scanning this gradient from left to right every 7.75 seconds. And that's it. So I've just substituted with this, with the default input, if this switch is true, which means if our value is 0. And it is 0 if it is 0. Yeah, what I do then is just multiply the whole thing by 3 to make it way brighter. And that's to trigger the... that is to basically make the glow post-processing effect, apply a little bit of a light corona bloom glow to it. And that's how the shader works. So we have a bunch of different parameters. So we can configure the color of the basic color of the display. We can configure the warning color. We can configure empty warning. Yeah, we can configure if there is even going to be an empty warning. Aha, because not every bar wants one. And I was adding these features on top of each other one by one when I was, first I made this bar, then I made these bars, then I thought, okay, I want to be able to disable this warning because it might not make sense for these ones. This is where this bitwise AND operator comes in. So first we take the value and we see if it's 0. If it's 0, we're empty. But if we're now just gonna check if this instance is actually going to use the empty warning. So we have this Boolean parameter, and now we're doing a bitwise AND operation, which means that it outputs true or 1 only if both inputs are true. And of course, there's a bunch of other operations you can do. This is pretty much an operation on floats, but we're treating them as bits, as booleans. And this means that both the value has to be 0 and this has to be switched on in order for this switch to ever redirect and show us this result instead of the basic one here. That's the shader. Now let's go to the code. So the ammo display was the first one that I made, and it's driven by the weapon script. Oh yeah. So projectile shooting weapon. What I do first is maybe I can make the code bigger. Yeah. So what I do first is define a ammo display mesh instance node path, just a variable to help me keep track of where the display is. And that's an export. So in the editor, I can click on my weapon here, and I have ammo display mesh instance, this field. This means I can, take and drag a node here. And this will be stored in the weapon node, not in the script. This is awesome because I can reuse the same script for different weapons, having different models, having different display layout, and just, assign something else here. I can add a few other ones and just, leave some empty, use some configured displays here. The goal is to have reusable code, so I don't have to, make a different version of the script for a different weapon. Unless it's a, wildly different weapon. Wildly different weapon. I'm going to undo to keep this display ammo here. Right, so in the script, first I define this node path variable, which is exported. That means we have this parameter here, shown in our node. Then we have a, non-exported variable ammo display, which is the actual reference to the actual node. And this has the onReady annotation, which means that this will only be processed, this assignment will be processed only after this node joins the scene tree and all of its children are also there. Which basically means that this weapon is already present and everything is done. So it's ready, onReady. And that's necessary because if I didn't do this and just try to do that, this get node would fail because this would execute immediately after this node is actually when the script is being compiled and it doesn't, or when the node is being instantiated and its children don't exist yet, and this one doesn't exist yet because they're spawned from top to bottom and then called ready from bottom to top. So yeah, without onReady, this isn't gonna work, but it can work and it works with onReady very, very well. So here I just define a type to be sure that I'm assigning the right thing. Because, if I by mistake assign, something else, this is gonna throw me an error. I'm gonna find my error quicker, easier, find out that I messed up. And then I do get node and pass the node path variable. So this gives me a reference to a specific node. Right, now we have a method I made called update ammo display. So yeah, this is quite, hard coded right now because this is called update ammo display. The variables above are called ammo display, this and that. But this can be generalized later for different things. But, you always have to start somewhere. This will probably go through a couple, iterations of refactoring over the next years, etc. But I think it's an interesting thing and it's worth taking a look at it. So we have the method, I made a method called update ammo display, which will take a float. I didn't specify that it's a float because if it doesn't get anything passed in here, it's just gonna have a null. And that gives me the information that I need to fetch that value on my own. And this all came it was iterated. It was an iterative process when I was first made this, and I was like, okay, I want to assign a value. Okay, but now I want to override that value. So I need some way to know if I want to, automatically find the value for the amount in the shader, or do I want to override it with something like 1 or 0? And I found I want to override it with something when I, for example, reload the gun. Because I want to change this value mid-animation when the magazine is off screen to create the illusion that we're taking out a magazine and putting another one or the battery. So I had to do this thing. Right, so we have the ammo amount parameter. It's by default, it's set to null. Now, first thing is we check if there is a node assigned to the ammo display. Because if there is nothing there, let's just skip the whole function. Nothing to do here. Right, with that out of the way, we check if there was any information about the ammo amount supplied. If there was not, we are gonna deduct that ourselves. So we're gonna make sure it's a float, because sometimes this gives me, this gave me an int, and my display was either on or off, which was kind of silly. I've had this in GDScript in Godot 4 happening a couple times, where if I don't take great care to make sure that my calculations are done in float, sometimes some parameter is an integer and it gets, you know, rounded to an integer, and it totally messes up the logic. Right, so first I take the first magazine that the weapon has, and I check the remaining shots. This is, you know, in your game it might be completely different, but I just take the amount of remaining cells, units, rounds in the magazine, and I divide that by the whole, how large it is. Basically, I get a percentage, or I get a fraction of how full the magazine is. And then I just assign it to here. It's that simple. However, if there was an information provided, we just use that information, which is just automatic. Because if this information is present, it's just going to be here. If it's not present, we are supplying it. Derpy Ninja Frog says that's in 3.52. Could you specify exactly what is in 3.5? Right, so then we assign the value to our shader, and this is an important bit. We take the node that we took the reference to previously. The node is this mesh instance 3D, which is our display. It's this thing. And we use a special method called set instance shader parameter, which basically accesses these instance shader parameters. Derpy Ninja Frog says division with integers is a problem in 3.52. Yeah, maybe that's the thing. I'm dividing somewhere, and it always, if you divide with an integer, it always returns an integer, even if you're also using a float in the equation, or rather expression. Right, so we use the set instance shader parameter. We give the name of the parameter, which is this one value, and then we pass the value that we want to assign to it. And that's all. That's what this thing does. Now, where do we actually call this? This has to be called every shot, right? So when you shoot, actually, let's see where we're calling this. It's been a couple days since I coded this thing. Update. Right, so update ammo display is called on in a method called reset, and this is called by the game when you respawn on all of your weapons, so that you can refill all your ammo, because otherwise you just spawn with, you know, and maybe an empty magazine, which is kind of silly. So we refill all magazines, however many there are. And also I'm running update ammo display to 1.0. So we're overriding the value. No matter what's in our magazines, we just send 1.0 to make the bar look full, which is going to be this. Of course, we change the color, etc. And we all did the grid thing. No matter. Right, so reset is called on ready, just to, you know, start. Then where else is it called? It's actually called it's not called anywhere here. Where it is called is in the animation player. The animation player is holding a few animations. There's reload, shoot, and shoot 2. Shoot is for primary fire, which means it's a quick shot. And what this does, you can see, is I have an animation track that calls a function, which is something I really like about Godot. So you can click here, add track, call method track. Then you pick a node that you want to call a method on, and it doesn't have to have a script. You can take anything. And then you can just, add a key, insert key, right click, insert key, and you select a method, and you can just call anything. Like you're creating kind of a script with this, which is timed. It's crazy. You can do anything you want. So what I do, let me delete this track. What I do is I call update ammo display with a null. And this is important. I have to pass a parameter to this function because it expects one. So I just specify there's argument count 1, and I don't give anything. And the default is nil, which is not in list, which means we don't pass anything, which means this null gets used as default. Also, nil will as well just, trigger this if and cause this method to just fetch the amount of ammo on its own. Now, why is this in the animation? I could do it in code. The code updates the magazine to, remove one shot. This is all done in a different parts because there's a bunch of components, the barrels, slides, etc. But because this is done in the animation, I can control exactly when does this switch change comes. So, we are shooting here and here, right in this spot, the bar will update. It doesn't have that much of a meaning. You don't really see that in game. And then shoot to is the secondary fire. This is a much slower and heavier shoot animation. I'm pretty happy with this, sliding in buttstock. It's really cool. Like pneumatic buttstock. Really fun. And we also call this update ammo display with a null parameter. So it also updates. Now we have a reload animation. And with reload animation, with the reload animation, we are calling this. Now, if you're reloading, you probably are kind of empty, but we don't know how much ammo you may have left in the battery. So at this point, we call update ammo display with a parameter, which is an argument. This time it's a float, and it has a value of 1. And this is a moment in the animation where, like when you view the game like that, where the magazine is off screen. So we have an empty mag here. Now it's get refilled, and then it comes in here and it looks like it's a new one, but it's the same one. It's just the animation updated. And that is pretty much it for the ammo counter. The next thing are the individual fire mode displays. So there's primary and a secondary. What I did is there are slides. A slide is a kind of a abstract part that controls the timing of the weapon. And also it controls of how much ammo does firing it consumes, or rather loading. And yeah, it also defines what magazine it pulls ammo from, because you can have 2 magazines. You could have an SMG with a grenade launcher, and grenades and rounds are not interchangeable. So we actually have 2 magazines in the gun. We don't have such a weapon, and maybe we won't, because this game is not, going for realistic guns or anything like that. But who knows? We might have. And there's also a difference to the display. And I called it slide display because it's no longer an ammo, it's showing the progress of the slide rollback, which is kind of funny. So when I go to the slide script, you'll see that I'm also defining a node path like in the weapon script. And I just call it slide display instead of ammo display. And slide display, we get the node, it's on ready, just like before, and we have a method for updating slide display. Again, slide progress equals null. This time it's called slide progress. And if there is no slide display, we just don't do anything. And if otherwise, we just set the value passed. As you can see, there is no option to, like, this will not handle this will not handle a case where no value is passed. That will fail because you can't assign a null to. I think we can assign a null here, but right now in this code, I'm never calling it that way. So how is it called? How this is called is pretty funny. So here we have the slide rollback progress variable, which is a float. It initiates at 0, which means the slide is fully rolled back, or it didn't start a rollback. And I define a setter. In Godot 4, you define a setter by having a colon after the variable definition, and then you do set, in parentheses value, colon, and you define your setter function. And here, what I do is first, the most important thing in a setter is to actually set your value. Set your value, because the best thing you can do with a setter is to forget to do this. And then happy debugging. Yeah. Now, debugging bugs like that is really fun. I don't recommend it. So don't forget to set your variable in the setter. It's not happening automatically. And then what I do is I call update slide display with this value. So that this code is called every time this variable is changed. Which means this value automatically propagates to my shader, or rather to my instance shader parameter. Something like that, yes. And okay, so now what is gonna set this? Haha. There's the function shoot in the slide. The slide has to be ready, which means it must have already returned. And now if there is no magazine, which means infinite ammo, or the magazine managed to feed enough ammo into the slide, that means we can actually shoot. Now we create a tween. Tweens are awesome. If you don't know what tweens are, in Godot 4 they have gone through a huge overhaul. They're amazing, and I'm doing most animations in Liblast with tweens, from UI to character depth and a bunch of other stuff. Particles, muzzle flashes, everything uses tweens. Tweens are awesome. So we create a tween, and then we interpolate the property using that tween. So we tween the property on object self, which is this very node. We just put the name of the variable, put the value we want to end up on, and put the amount of seconds we want this tweening process to take. And then you can also define a bunch of stuff. So I make sure that we're starting from a value of 0. I also connect a signal to, or rather, I connect a method to the finished signal on the tween, which means once this is done, this method is going to be called. And this method sets our slide ready to true and emits a signal, which is also, used somewhere else. Blah, blah, blah. Right, so this tween now is started, and it's just going to change the variable of every frame. And that will also call this setter, which will also call this update slide display, which will also pass the current value of the slide rollback progress into the shader, which makes these progress bars, so to speak, just get animated. And that's pretty much it. Right. I think I'm going to cut it here. I've been live for 45 minutes almost. I think this is enough for now. Let's maybe not bother with this grid thing. I leave this as an exercise to the viewer. Okay, thank you so much for watching. I hope this was interesting, maybe inspiring. Maybe you want to do something similar, or maybe you have ideas of what I could do better. maybe you have better ideas on how to implement that kind of stuff. This could be done with meshes, but then I can't animate things as easily. I might have to actually do a version with meshes to, be able to run in a legacy OpenGL renderer that doesn't support custom shaders. We'll see. This isn't, a mission critical, so it might not be worth spending the time to get it to work, at least not at first. Okay, that's all. Thanks for watching.